There.
I guess it's kind of time anyway.
Let me make sure that the audio's right. Actually, well, yeah. All right. Okay, I think that's good. I think you're good to go.
Cool.
And then I have the slides on
Desktops.
one of these. I think it's here.
Yeah. Huh?
That one.
Oh, I closed it.
And, all right, you're good.
Lit. Okay.
Don't forget to share your screen on Zoom.
Smart. Okay.
Yeah, share the desktop. Sorry,
Oh, you're good.
I'm hovering. Yeah,
Okay.
there you go.
Whew.
They can see this, so like just keep it like because it's.
Oh, I see. Okay. Sounds good.
Cool.
Nice.
Yeah, make sure that they can see the before.
Yeah, I think I could see it.
Right. It's
Okay. Hi, everyone. For those who don't know me, I'm Isla. I'm going to be giving the lecture today. Yeah, so today's Tuesday, week 3. Hope everyone had a good Labor Day weekend and is excited to be back. I know I'm kind of sad about being back at school, but it's cool. We're here, we're doing it. Awesome. So some quick announcements before we start. The first homework is due on Thursday, right? So typically homeworks for this class are due Tuesday before lecture, so that would be like right now. But because we like uploaded it late, it's gonna be due on Thursday. Also note on the second homework that's gonna be released after lecture today, and that will be due next Tuesday. The attendance form can be found at this link, or you can scan this QR code. So go ahead and do that so you get your participation points. Also, our office hours are finally scheduled. So a list of the office hours are right there. We have them all 5 days of the week, which is kind of cool. And they're all in Campbell 121. So Ralph already has his today, but I have mine tomorrow 4 to 5. So feel free to come. And if you need help for the homework, awesome. Does anyone have any logistic questions about the homework or office hours or anything like that? Cool. All right, so quick recap of what we did last week. We went over different data types. Let's do this, okay. We went over different data types. So integers, floats, strings, lists, dictionaries, tuples, and Booleans. We also went over functions, how to construct functions, how to call functions, how they're useful, how you can use them, and also variable scope. So whether you're defining a variable within a function or outside of a function, and how that affects how you can use it. But something to note about what we've learned so far is that our code can't make any judgments. So our code won't change based on any of the variables that we input. We need something called if statements in order to make our code make judgments. So before we get into what if statements are and like their syntax and everything, we need to go over Boolean operations. So these are a list of a bunch of different operations in Python. I've kind of highlighted some in red, the ones to note right now. So these two I just pointed out just because I want to reiterate that this ampersand is not the normal and, so don't use it. And the caret is not the normal exponent, right? It's the double asterisk, so don't use it as an exponent. But on to Boolean operators. So we have these greater than or equal to, less than or equal to, and less than operators. So how you would use these is just kind of normal, like you'd say 1 is less than 2, and that would return a true value. I'll be going over examples on how these are used a little bit later. Something similar is double equal sign and exclamation mark equal sign. So double equal sign is basically equals to. So a single equal sign is setting a variable to a certain value. So we can't use that same symbol. So it's a double equal sign. And then the exclamation mark equal sign is not equal to. So it's like, the equal signs with the slash through it, but you can't do that on the keyboard. So it's exclamation mark equal sign. And then and or, these are two other Boolean operations, which are defined like so. So here you'll have a statement here, and neither the operation and or. And then, oh, this is in the way. And then another statement here. So how these work, here are the rules for them. For and, it'll return true if both the statements are true. So if you have 1 equals 1 and 2 greater than 1, it'll return true, right? Because both of the statements on both sides of the and operator are true. But if one of the values or one of the statements is false, it's going to return false. So for the and operator, both statements have to be true in order for it to return true. If one of the statements is false, it'll return false. And moving on to the or operator, it'll return true if only one of the statements is true. So this is different than the and operator, right? Instead of both having to be true, only one has to be true for it to return true. And then it'll return false if both of the statements are false. So for and, it'll return true if both are true, and or will return false if both are false. Sorry, that's like a lot of like true, false words. It's kind of confusing. Does anyone have any questions? I'll be going over examples in a sec. Awesome. Okay. Feel free to stop me at any time. Okay. Awesome. So here are like 10 quick questions that I want to go through with all of you about using these different Boolean operations. So let's just start with the first one here. True and true. What do we think this will return? True or false? True? Yeah, right, because both of the statements on either side of the and operator are true. So it will return true. So next on to 2, true or false? True. Awesome, yeah, right, because we only need one of the statements to be true. Next, 1 is greater than or equal to 2. Yeah, false. 5 modulo 2, right? So modulo is you're dividing by, it's 5 divided by 2. And what's the remainder of that? 5 divided by 2, or 5 modulo 2 equals 1. Right. 5 divided by 2, the remainder is 1. Now on to 5. 2 is not equal to 2, or 1 is equal to 1. Right? True. And then this is the same one, number 6. It's the same as 5, except we don't have these parentheses. What do we think it'll return? Any guesses? Yep, it's the same. These parentheses are here, kind of just easier to read if you want to, but they don't change what it returns. So on to 7, 3 divided by 0 or true. What do we think? I heard error. Does anyone else have any other guesses? Oh, someone will raise your hand. I can't really hear what anyone's saying. Yeah, back there. True. Okay. What do you think? Right. Any other guesses? Yeah, so this one's kind of tricky. It is an error because it's evaluating 3/0 first, which raises an error. So Python can't read any further. It'll just return the error. But on good intuition, like it would return true if it wasn't an error and it was just a false value. Okay, now on to 8. True or 3/0? I heard true. Any other guesses? Yeah, exactly. So for this or statement, we only need one of the statements to be true. So once it reads the first true statement, it can stop reading. So it won't even process the second statement, which is an error. So it'll return true. And then how about this last one? False and 3/0. Yeah, so same as before, kind of. Because and needs both of the statements to be true to return true. It reads this false in the and it knows that it has to return false. So it doesn't even read the error. And then the last one, not 2 equals 1. What do we think this returns? Yeah, so this returns true. 2 equals to 1 is false, but not false is true. Yeah, so a lot of these are just more tricky than anything. You're not really going to encounter much of this, but just some things to note. Does anyone have any questions about any of these? Yeah.
It's like 4. Like, what's an example of when this would be like really common?
Yeah, no, that's a great point. I'm actually like gonna get right into that right now. Yeah, so what are these for? These Boolean operations are essential for if statements. So what's an if statement? So let's say for an example, we wanted to write a piece of code that outputs a certain thing if a variable is above, let's say 10. So the logic behind that, we have this input variable x. We compare x with the value 10. Then we have these 2 branches. We decide whether x is greater than 10. We want to print x is greater than 10. Or else we print x is not greater than 10. So that's the logic behind it. We want to write this in code. It'll look something like this. So this x equals is simply a prompt for a user to enter a variable. It's not super important. But this is how an if statement is formatted. So the first is if, and here we're checking, is x greater than 10? Then we have this colon, similar as you would like use it to, as like defining a function, you need the colon at the end of the line. We start a new line, print x is greater than 10. So we're checking if this condition is true. If that condition is true, you go inside that statement and you do the print statement. If that's not true, so else, colon, we print x is not greater than 10. So that's kind of the general format of what an if statement looks like. This is like a really simple example. Another element to an if statement is an else if statement. So the logic behind that, what if we also want to consider whether x is equal to 10? So same flowchart as before, except we have this other branch of x is equal to 10. We want to output something different. So same code as before, except this highlighted part here. This ELIF is an else if statement. So we're checking is x equal to 10. So x is equal to 10. We want to print x is equal to 10. So when you're thinking through this, first, the code reads the if statement. If that statement is false, then it goes to the else if statement. If the else if statement is also false, then it goes to the else statement. So the ordering of the statements is important when you're writing the code. Yeah, so we sent an announcement a little bit before about like a Jupyter notebook to download. So if you want to go ahead and download that or open it up now. I have some demos that I wanted to walk you all through. Let's see if I can find it. So if you don't have it downloaded, it's under files, lecture demos, and it's the only file in there. So I already have mine downloaded. So I'm just going to open it on up. Let's see. Yeah, if for while demos. Great. And if you can't follow along right now, that's totally fine. I'll be sharing my screen. But if you can have it open, we're going to be doing some coding together. So it'd be really awesome if you all could open it up because it's really helpful to try the coding yourself. So here I just inputted the example that I showed on the slide before. If you want to try running that cell, yeah. What's that, sorry? Yeah, so if you go to the B courses, yeah, you'll have to download the notebook. It's under files, lecture demos, and it's the only file in there. yeah, no worries if you're having trouble downloading it or anything. I know the Wi-Fi's been really spotty lately, but I'll be sharing my screen here. So this is just the example that I showed just now. If we run this cell, we'll get this prompt to enter an integer, and then we can enter anything we want. Let's say we'll enter 11, and it tells us the correct answer, that x is greater than 10. So that's just an example of how it works. Yeah, is anyone having any trouble like running it or downloading the notebook or anything like that? Yeah.
I just can't get into the courses because I can't hear the two guys.
Oh, gotcha. Yeah, no worries. You can just look up here. No worries if you can't get it. Okay, cool. Yeah, so let's say we wanted to kind of a slightly different scenario. Let's say we wanted to see if x can be divided by 2 and 3. So instead of checking whether it's greater than 10 or equal to 10, checking whether it's divisible by different numbers. So again, going to that notebook, I kind of have some template code for you all, and I'm going to go through and show you what that might look like. So we have the same lem as before, where we're entering an integer or prompting the user to enter an integer. So first we're going to check if x is divisible by 2. And to do that, again, it's just a modulo. So we'll do x modulo 2. And we want to make sure the remainder is 0, right? Because if it's divisible by that number, it'll give a 0 remainder. Then next, we want to check if it's divisible by 3. So same thing, but instead of divisible by 2, we're dividing by 3. So notice that you can nest these if statements within each other, and you can do this as many times as you want. Here we're just using 2, and it runs just fine. So here we're checking if it's divisible by 2, then by 3, and then we'll print x is divisible by 2 and 3. And then if that's not the case, if it's not divisible by 2 and 3, we want to print not, we want to make sure it's in quotes, not divisible by 2 or 3. And if we run that, we get a similar thing as before. Let's say we'll type in 6. We'll say that x is divisible by 2 and 3. Can anyone think of a way to maybe do this without a nested for loop, just having one line? Yeah. Yeah, exactly. So instead of having these nested if statements, we can use one of the Boolean operators that we talked about earlier. So I'm just going to make a new cell by clicking this plus, and I'll copy this code. And instead of having these nested if statements, I'll just leave it as one if statement and add in an and. So x modulo 2 equals 0 and x modulo 3 equals 0. So running it, we'll do the exact same thing. Awesome. Does anyone have any questions about if statements, nested if statements, anything like that? Awesome. So we're going to come back to this in just a sec. But yeah, this is the code that I just wrote essentially. But now I want you all to try an example on your own. So this is kind of a similar thing as what I just showed, but instead we want to consider different cases. So we also want to consider the cases when x can be divided by 2, but not 3. X can be divided by 3, but not 2, or it can't be divided by either number. So moving back to the notebook, I have, again, this template code here. If you want to work maybe with the people around you, I'll give you a couple minutes. Come up with what you think might work in order to solve this problem and consider all the different cases. If you don't have the notebook up, maybe just think through it, talk about it with the people around you, or you can write it down, whatever works best for you. But I'll give you a couple of minutes to do that. Oh, yeah. Hmm?
Like, I don't think they can see it when it's like that. At least I can tell.
I don't know. Okay. It's just in the way, so.
Yeah, I mean, like, at least while you're doing like the demo, maybe.
Okay.
You don't have to.
Yeah.
Not the one. It was like at the end of the second lecture.
So what's that? Whatever you want.
So just do like, if not the thing you want to say.
Oh, I put the not for the
Yeah, you're like saying, yeah,
not for the not.
yeah. And then it's saying it's not true.
All right, how are people feeling? If you want more time, feel free to give me a thumbs up. Do people need more time? Okay.
Bored.
Oh. All right, give me a thumbs up if you're ready to go on. Awesome. Okay, we'll go through the solutions together. So if you're not quite finished yet, no worries. Great. Okay, so does anyone want to tell me what they think this first statement for the if statement could be? I guess it could be a different things, but yeah. X% to equal to 0. Mm-hmm. Right, yeah. So checking whether it's divisible by 2 and 3. And if that's the case, what do we want to print? Right. By 2 and 3. So how about the next statement? Does anyone have any idea what we could write for that? Yeah. Sorry, could you say that again? I had a little trouble hearing you. Right, yeah. That totally works. And then x modulo 3 doesn't equal 0. Yeah, so something else we could do is, because we're already checking if both are equal to 0, we can actually omit this second statement. And we can just have else if x modulo 2 equal to 0. But they were both run the same, so it doesn't really matter. And then this other statement is essentially the same as this one, except we're flipping it around. So here we'll print divides by 2, but not 3. Yeah. No, they work the same. I think for some reason I just prefer this one, but the quotation marks work the exact same. Yeah. And then for this one, divides by 3, but not 2. And then here, not divisible by either. Cool. And if we run this, we'll get what we expect. Yeah, so hopefully that was useful to work through an example on your own. Does anyone have any last questions on if statements? If not, we'll transition to for loops. Awesome. Okay. So right now, if statements kind of giving us more control over our code. We're checking whether a variable meets a certain condition, and we're changing our code based on that. But what if we want our code to run multiple times? So let's say we want to run the same piece of code 100 times. Right now, we don't have a way to do that. And if statements don't do that. But something that does, and kind of my personal favorite, are for loops. So this flow chart kind of goes over the logic behind a for loop. So for each item in a sequence, so that could be like a list, we're checking whether that's the last item. If it's not the last item, we're reading the statements inside of the for loop. Once we read those statements, we loop back to this. We check, is that the last item? If it's not, again, we read the statements inside, and we continue until the last item is reached, and then we exit the for loop. So what the for loop looks like, for each item in a list or a sequence or whatever it is, colon, and then inside, we write whatever code we want to do. So that's kind of the general format of what it looks like. Yeah, so it's iterating over items in a list. or whatever you want to iterate over. Like for example, if you wanted to print the numbers 0 to 100, it's kind of a tedious task. It would take you a long time to do by hand. But with using a for loop, you can do it really, really simply, really, really easily. So how do we go about doing this? So we write a really simple for loop. We'd say for I in range 1 to 101, and then inside of the for loop, we say print I. So this is for every number within this range, we're printing it out. And the reason we're going from 1 to 101 and not 1 to 100 is because this range excludes the last value. So that's just something to keep in mind, that it excludes the last value. So we go back to that notebook. I've included that example right here, except I have 1 to 21 just because 100 numbers is a long ways to print out in your notebook. But if we run this, we'll see that it prints out all the numbers 1 through 20. And then you can change this to whatever you want and it'll print out however many numbers you want. Not super exciting, but yeah, go ahead. The same line. Yeah.
Yeah, if you just Google like how to print repeatedly without using a new line on Google, it'll like show you. It's like one argument or something. It's just like a
Yeah. Yeah, no, that's a great question. So actually we don't need to use the letter I. It can be any variable that we want. So I can call this var, but I need to be consistent. So wherever I have I need to change that same value. So instead of I, if I want my, my dummy variable to be var, it works the exact same. And it can be whatever you want. Yeah. Any other questions? Yeah. Nothing happened. Were the ones before working? Were the like if statement cells working for you? No?
No,
Okay.
mine was exactly how it was up there, and I was select the next.
Okay.
I can go home.
Okay. Yeah,
It's the
it
same.
sounds like something might be going on with your notebook or something. Yeah.
Well, now it actually.
Yeah, so I don't know that off the top of my head, but apparently there's something you can look up. And you can add another argument to your quick statement to make it all go on. Yeah, you can just Google it and it'll, yeah. All right. Sounds like we're having a couple issues with the notebooks themselves, but does anyone have any questions about for loops or like the syntax of this or anything?
I
Yeah.
think I know what this is. But
Oh,
for
what's that?
anybody who It's not running. There's a cell above that is asking for an input with a white box, with a black outline. Just type in a number. It's asking for your input. It's waiting for you. That's why nothing comes after that.
Gotcha. Thank you. Yeah. As a string. Uh-huh. Wait, sorry, what's your question again? Sure. Yeah, so it's just this range like function. Just when you're looping through it, it just excludes that last value. Yeah. Right. Yeah. Yeah. I mean, you're not always looping over a range. You could be looping over a list. Just for this example, I just have it as a range. Yeah. Cool. Now I kind of wanted to go over this more more advanced example than just printing out numbers. So this is looping over a list. So for example, here I have a list of some astronomical object names. So I have some supernova, some galaxies, some black holes. And here, if we wanted to print all the objects in this list, we do the same thing as before. Here, I'm calling my list. And as we mentioned before, we can use any variable that we want to loop through all the elements in this list. So I can just call it because object seems to be something that Python has defined. So I don't want to overwrite that. So I'm just going to be saying obj as my variable name. So for each object in objects, I want to print that element. And if I run it, oh, well, first I need to run the above cell and define my list. And it'll print out all the objects that I have in that list. Cool. Yeah.
So it knows.
Yeah, so we're pretty much defining the variable right here. So this variable could be,
Oh, in that line.
yeah.
Oh.
So as long as you're consistent within your for loop, you can use whatever variable you want. So here, if I run it with I instead of what I had before, it runs the exact same.
What else would you?
Yeah.
Except for like not
Um,
like what else do you is that why the spot itself?
um, yeah, so it can be any variable name. So something you want to keep in mind is if you're writing a bunch of code, keeping track of your variable names, because if you have a different variable defined as something, you can kind of like overwrite that with this for loop. So just keeping track of your variable names is important. Yeah.
Is the scope of I just in the for loop, or can you do outside?
Yeah, it's just in the for loop. Yeah. Cool. Yeah.
Actually, sorry, really quickly, I want to fill off that. If you're curious, run a for loop using I and then call I in a different cell after and see what happens.
Yeah.
Like that'll tell you whether or not it's like local or global or what's I being written out.
Yeah, did you have a question? Uh-huh. Yeah, so let's see, I'm trying to think of the easiest way to do this. Because if you just did I plus 1, what's that say? Uh-huh. Yeah, so I think the easiest way to approach this would be doing like a while loop, which I'll get to later, where you're kind of defining the dummy variable yourself. And so you can like add different increments to it. But for for loops, it's easiest if you just loop through all of the elements within the list. Yeah.
You can also use like list indexing. So
Yeah.
going back to our like first couple lectures, you could actually use indexing to skip every other value if that's what you wanted. But like Isla said, it's much easier to do that.
Yeah.
So then I wouldn't have you try to just protecting OBJ outside of the for loop, right? And it's yeah, it just picks up a object. So it is returning. I think it's returning the last one in the list.
Gotcha. Yeah, so that makes sense. Is that it'll return, like it's not going to be redefined after that, but it'll just be whatever its last, it keeps redefining that variable within the for loop. And then once it exits the for loop, it's stuck as the last value. So I guess, yeah, it is defined outside of it, but not super useful. You don't want to really be using it. Yeah.
The thing I noticed is like if I like set I equal to 1 and then I go to the for loop, the last one it'll set it to the full in that for loop. So you want to be careful. If you like use I for something else and then you go into the for loop and use it and it'll replace it with that last.
Yeah, exactly. So just, yeah, go ahead.
I was going to say common practices for coding you typically keep like your for loop variable names really short, like I, J, K, if you're like doing like integer like looping, or like how Isla did OBJ short for objects, to something that like you're never gonna really use again, just only use it.
Yeah, and sometimes you'll use like multiple for loops. So you kind of want to, sometimes you might want to be descriptive with your variable names, so you kind of know what you're looping through, because it can get kind of confusing. Any other questions? Cool. And then the second part of this example, it's a little bit trickier. So like we had nested if statements before, we can also have nested for loops. So it's like doing a big loop, and then within that big loop, it's doing a little loop. So it's lots of looping. It's not super efficient, but sometimes you got to do it. So here, as an example, as a nested for loop, let's say we want to print all the supernovae in this list. So that's all of the objects that begin with SN in the string. And remember from before that we can index a string just like we can index a list. So to obtain the first element of a string, you can do those bracket 0. So in the same way that we can iterate over a list in a for loop, we can also loop through a string in the same way, which is kind of neat. So I'll show you what that'll look like. So same thing as before, we want to loop through all the objects in our list. So I'm going to use, instead of I, OBJ again, just because it's more descriptive, because I'm doing this double for loop. So for OBJ in objects, if I can spell. So for each object in objects, I'm going to be doing this like kind of a pretty crude way and just checking if there's a capital S within the string. This is kind of cheating a little bit, but I just want to show you what a nested for loop looks like. Here in on all these objects, the only objects that have a capital S in their names are the supernovae. So we're just going to check if within this string, is there a capital S? If so, we know that it's a supernova. So we're going to say for letter in OBJ. So we're looping through all of our objects in our objects list. And then for each of those objects in our list, for each object, we're looping through all the letters in that object. So here you can say it's a little bit easier if we use more descriptive, like dummy variable names, or else it gets kind of confusing. So for each letter in each object, we want to check if letter equals capital S. And if letter equals capital S, we want to print out that object. And if we run this cell, we get what we want. We get all the supernova in that list. Cool. All right. Any questions about this last example? Yeah.
So, I can't do like S instead of S. So I was wondering like why.
Yeah, so when we're doing for letter in object, it's just looking for one character. So if you're comparing the one character to like two characters, it's just never going to really match up. Does that kind of make sense? Because we're treating each character individually within the string. Yeah. So another way we can also do this, let me zoom out a little bit. Don't have a ton of time, so I don't want to get too into it, but for object in objects, this is kind of a better way to do it instead of the nested for loops. We can use an if statement or like a Boolean operator. So for object and objects, if object 0 equals S, and object 1 equals N, we can print object. So this is just using like string indexing. And it's checking the first element and the second element of each of our objects. And we get the same thing. So this is kind of a more efficient way to do it, but I wanted to show you guys what a nested for loop looks like. Cool. And so I don't have a ton of time left, but I definitely want to touch on while loops. So I'm going to go over that quickly. So a while loop is similar to a for loop in that, well, it's doing a loop. But instead of looping through a sequence, it's looping through until a test expression is false. So this is how it's formatted. While a value is true, colon, do the code within that while loop. So what that might look like, if we wanted to print numbers 1 through 5, we can set this dummy variable here, I equals 1. And then while I is less than 6, print I. And then we want to make sure we change I, because if not, our while loop will run forever. Because we're checking that condition if I is less than 6. And so this notation here, plus equals, is basically adding 1 to the already value of I. So if I is equal to 2, plus equals 1 will give an I value of 3. Yeah. Yeah, so you can add whatever you want. If you wanted to do 1/2, then you'd be going in increments of 1/2. Yeah. Plus plus, no.
Plus plus is the same thing as plus.
Oh, is it?
Basically. Well, I'm just saying like what you're used to, if you're used to like C plus plus or something, I plus plus, the equivalent is I plus equals. And that does the same thing.
Yeah, and then this goes back to your question before. If you wanted to make it print, every second one or every third one or whatever, instead of doing plus equals 1, you could do plus equals 2 or plus equals 3. And then it's going to be skipping over certain numbers. Awesome. So I'm just out of time, but one last point that I wanted to make is if we don't change the I or whatever value we're checking within our while loop, it'll run forever. And that's not great. That'll like kill our computers. So you want to make sure you are changing this test expression. So in this case, we want to make sure we're adding to I so that eventually our while loop will stop. Does anyone have any questions about that? Cool. I had some demos I wanted to go over, but maybe I can just send them out later and you guys can take a look. But does anyone have any questions about anything I went over today? Cool.
We can also pick up where we left off next time.
That's true.
a little
Yeah.
bit.
All right. Well, that's all I have. Feel free to stick around if you have any questions about anything. If not, you're free to go.
Look at that. Right on.
Hey.
Stop.
Mm.